to the video tutorial brought to you by the X function. Our team will be leading you through this course. By the end of this course, we hope that you will be able to solve your own equation regarding to the topic that will be discussed.
Differential equations. It is an equation for a function that relates the values of its derivatives. There are some topics that are involved in differential equation, such as separation of variables, homogeneous equations, exact equations, linear equations, of order 1, determination of integrating factors, Bernoulli's equation, and integration by inspection. This course will focus on the integration by inspection.
Integration by inspection. Integration by inspection, also known as integrating factors found by inspection. There are 4 exact differential that occurs frequently. Namely, first, the derivative of x and y is equals to x dy plus y dx. Second, the derivative of y over x equals to x dy minus y dx all over x squared. Third, the derivative of x over y is equals to y dx minus x dy all over y squared. And lastly, the derivative of arctan y over x is equals to x dy minus y dx all over x squared plus y squared.
Let's have our first equation. Our first equation would be y times y squared plus 1 dx plus x dy is equals to 0. Let's have a closer look.
Y times y squared plus 1 dx plus x dy is equals to 0. Distribute y in the first term. Then we have y cubed plus y dx plus x dy is equals to 0. Then distribute the dx to the first term. So we have y cubed dx plus y dx plus x dy is equals to 0. Now we have one of the 4 exact differential equations. So let's substitute the value of y dx plus x dy, which is d of x and y. So we have y cubed dx plus d of x and y is equals to 0. Now let's proceed to the integration. The integral of y cubed dx plus the integral of d of x and y is equals to the integral of 0. In here, let's make y cubed as a constant. So we have y cubed integral of dx plus integral of d of x and y is equals integral of 0. Then do the integration. Y cubed x plus xy is equals c, or xy cubed plus xy is equals c.
Let's have our second example. We have y times the quantity of 2xy plus 1 dx minus x dy is equals to 0. Let's take a closer look.
Y times the quantity of 2xy plus 1 dx minus x dy is equals to 0. First, distribute y and dx, then copy the remaining terms. So we have 2xy squared dx plus y dx minus x dy equals 0. So we have again 2xy squared dx plus y dx minus x dy equals 0. We have to multiply both sides by 1 over y squared in order to have one of the 4 exact equations. 2x dx plus y dx minus x dy over y squared is equals to 0. Substitute the terms with their corresponding equation of exact differential. So we have 2x dx plus d times x over y equals 0.
Integrate and simplify. 2 integral of x dx plus integral of d
times x over y equals 0. Let's proceed to integration by using power formula. 2 times x squared over 2 plus x over y equals c. X squared plus x over y equals c. Then multiply both sides by y to eliminate the fractions. The final answer is x squared y plus x equals cy.
Let's have another example. Y times x squared minus y squared plus 1 is equals to x times x squared minus y squared minus 1 times the y prime. Now, let's take a closer look.
Y times the quantity of x squared minus y squared plus 1 is equals to x times the quantity of x squared minus y squared minus 1 times y prime. Since y prime is also equals to dy over dx, so we have to distribute dy over dx to y prime. So we have now x squared y minus y cubed plus y is equals to the quantity of x cubed minus xy squared minus x times dy over dx. Next is to eliminate dx. So we have to multiply both sides by dx. So we have x squared y minus y cubed plus y dx is equals to x cubed minus xy squared minus x dy. Next is to distribute dx and transpose the second term. X squared y dx minus y cubed dx plus y dx minus the quantity of x cubed dy minus xy squared dy minus x dy is equals to 0. Next is to distribute negative sign to the second term. So we have x squared y dx minus y cubed dx plus y dx plus the quantity of negative x cubed dy plus xy squared dy plus x dy is equals to 0. Next is to group y dx and x dy. So we have x squared y dx minus y cubed dx plus the quantity of negative x cubed dy plus xy squared dy plus the quantity of y dx plus x dy is equals to 0. Next is to group like degree. X squared y dx minus x cubed dy plus xy squared dy minus y cubed dx plus the quantity of y dx plus x dy is equals to 0. Next thing to do is to factor out. So we have, since x squared is common in x squared y dx minus x cubed dy, so we have x squared times the quantity of y dx minus x dy. While in the xy squared dy minus y cubed dy has the common y squared, so we have y squared times the quantity of x dy minus y dy plus copy the last term y dx plus x dy. So we have now x squared times the quantity of y dx minus x dy plus y squared times the quantity of x dy minus y dx plus y dx plus x dy is equals to 0. Next is to multiply both sides by 1 over x squared y squared to eliminate x squared and y squared in the first and the second term. So we have y dx minus x dy over y squared plus x dy minus y dx over x squared plus y dx plus x dy all over x squared plus y squared is equals to 0. Since y dx minus x dy over x squared is also equals to the derivative of x over y, and x dy minus y dx over x squared is also equals to the derivative of y over x, and factor out y dx plus x dy over x squared plus y squared. So we can have 1 over x squared y squared times y dx plus x dy is equals to 0. So we have now the derivative of x over y plus the derivative of y over x plus 1 over x squared y squared times y dx plus x dy is equals to 0. Next, then proceed to the integration process. So we have the integral of dx over y plus the integral of dy over x plus the 1 over x squared y squared times the integral of dx and y is equals to the integral of 0. So we have x over y plus y over x plus x over y all over x squared y squared is equals to c. So next is x over y plus y over x plus 1 over xy is equals to c. Then, to make it simple, we have to multiply both sides by x over y. So we can now have x squared plus y squared plus 1 is equals to c.
Let's have another example. Y times the quantity of x squared plus y squared minus 1 dx plus x cubed plus xy squared plus xy is equals to 0. Let's take a closer look.
Y times the quantity of x squared plus y squared minus 1 dx plus the quantity of x cubed plus xy squared plus x dy is equals to 0. Let's first distribute y dx to the first 3 terms and dy to the next 3 terms. So we have x squared y dx plus y cubed dx minus y dx plus x cubed dy plus xy squared dy plus x dy is equals to 0. Next thing to do is to group the like degrees, so we can now have x squared y plus y cubed dx plus x cubed plus xy squared dy plus x dy minus y dx is equals to 0. Then let's factor this out. Since x squared y plus y cubed has the common y, so we can now have y times the quantity of x squared plus y squared dx, while in the x cubed plus xy squared has the common x, so we can now have x times the quantity of x squared plus y squared, then copy the last term. So we can now have y times the quantity of x squared plus y squared dx plus x times the quantity of x squared plus y squared dy plus x dy minus y dx is equals to 0. Next, we have to multiply both sides by 1 over x squared plus y squared in order to have one of the 4 exact differential equations. So we can now have y dx plus x dy plus x dy minus y dx over x squared plus y squared is equals to 0. Since y dx plus x dy is equal to the d of x and y, and x dy minus y dx is all over x squared plus y squared is also equal to the d of arctan y over x based on the 4 exact differential equation. So we can now have the d of x and y plus the d of arctan y over x is equals to 0. Then, let's proceed to the integration process. So, the integral of d of x and y plus the integral of d arctan y over x is equals to 0 equals to xy plus arctan y over x is equals to c. The final answer is xy plus arctan y over x is equals to c.